Okay, so the funky thing about a cone problem as opposed to a cylinder problem is that the cone is change. Sorry, the radius of the cone is changing. It has a rate of change, where in a cylinder problem it is constant, which makes cylinder problems a lot easier. You can see this like if I draw a cylinder, that that's height. See, that's the radius. The whole way down, that radius is going to be the same. It's always going to be that length right there. However, if I draw a cone, you can see where the problem is. The further down I get, the smaller and smaller and smaller the radius becomes. Um, However, because a cone or because the what you might call it of a cone, the relationship between height and radius in a cone makes a triangle. Wherever you have a different, wherever the height will be, it will still be similar to the original triangle or the original height that it is. So basically, we can use the ideas of similar triangles um, to figure out our cone problem. All right, so let's read this. Water is draining from a conical tank with vertex down. So I'm going to draw a little quick vertex down. Yep. And then water is coming out of it. So that means at the rate of 2 meters cubed per second. So water is draining out of it means that the volume of the entire system, like the water level, is decreasing. It's going down, which means that our change in actually I'm going to write this over here. That our change in volume over our change in time is, or the change of volume is the the negative 2 meters cubed per second. Another way you can identify this is by just looking at the units, because if it's a cubed, it's probably going to be, I wrote that way too big. If it's a cubed, it's probably going to be volume, and if it's area, it will probably be squared. So that's how you can figure that out. Let me move this up here. So that's our first known. Um, the next thing they tell us is that the tank is 16 meters high and its top radius is 4 meters. How fast is the water level falling when the water level is 12 meters high? So what we know is that they're asking us about when the water level is here, when it's 12 meters high. But for some reason, oop, hello, Lily. For some reason, they tell us that the tank is 16 meters high, that this number here, this length here is 16, and that this length here is 4. The reason they do this is that similar triangle thing I was talking about earlier. We're looking for this triangle here, but they tell us this triangle, or what it's about, so that we can figure out this triangle here. Um, because we don't know the radius. They tell us that the height that we're looking for is 12 meters, and that we're looking for the change in height, the derivative of height. What we're trying to find. Sorry, the cat is sniffing my foot. So, we have to use this part here to figure out what is going on. The tank is 16 meters high, and its top radius is 4 meters. So if you look at that there, um, the radius is 4, the tank is 16. So height is 16, radius is 4, which means that oop, the radius multiplied by 4 is going to equal the height. So 4r equals the height. We know that is the relation. So now let's finally write out our problem. The volume of a cone is equal to 1/3 pi r squared h. Okay, right? Yep. Um, but the thing is, the problem with this equation is that we don't have r, and r is not a constant, so we can't just plug it in after finding whatever h is. So what we do to mediate that issue is to plug in the relation here. So we want to define h in terms, sorry, r in terms of h. So by doing that, we can just divide by 4 and cancel that out. So r is going to be equal to h over 4. And we can take that in and put it in here for substitution. So h over 4 squared. That's what that becomes because r is equal to h over 4. And we can put our other stuff back. This. Here we go. Now we just have to simplify this so it is a much neater looking equation that you want to take the derivative of and not whatever the hell this is. So I'll leave this 1/3 here and this 1/3 pi. I'll separate the inside. So 1/4, this is basically 1/4 times h. And whenever you are squaring something and it's one variable, or like one, not one variable, but like one thing, that square travels to each of the different terms in this. So you're going to square the top and the bottom. And so what this will become is 1/16th, because 4 squared, I'm going to write it like this so it makes more sense. 4 squared is 16, and h squared is h squared. But I hope this makes sense. This is equivalent because h squared times 1/16th, you would just move that h onto the 1. Hope that makes sense. I hope that didn't make that more confusing. But anyway, take that back to h. So now what we want to do here is put our constants together and then our variables together. And so our constants are 1/3 and 1/16th. And when you're multiplying two fractions, because these are being multiplied, um, you multiply the top and the bottom. So 1 times 1 is 1, and 3 times 16. Let's figure out what that is. 48. That adds up. So 1/48. We can just leave pi. Don't mess around with pi too much. Times h cubed, because right here we have h squared times h. And when you're multiplying variables, like if you had x squared times x, you add the exponent. So it'd be 2 plus 1, which is x to the third. Same dealio going on for h here. That's why we got h cubed. And from here, we can take the derivative because this is a much nicer thing to take the derivative of. In fact, it's got one thing there. You don't have to do product rule or nothing. So in here, the derivative of v is going to be 1, but we have to add our dv over dt. And then we've got this here. We want to move that 3 over here. So 3/48 h squared. We still have to add our dh over dt, as per usual. 3/48. What is 48 divided by 3? 3? 16? Okay, okay. Let me just rewrite this real quick. 1/16th h squared dh over dt is now our derivative equation, and now we can finally plug in all our crap that we've got. So dv over dt, we know that's equal to -2 meters cubed per second. Let's put in -2, and that is equal to 1/16th times h squared. H is equal to 12. 12 squared is 144 dh over dt. Because we don't know, that's what we're looking for. That's the only thing that we don't have to plug anything in, because so let me do 144. I'm just going to do that with a calculator. Do this right now. I want to make sure I'm on. Okay, 9. -2 equals 9 pi dh over dt. Just further isolate this. -2 over 9 pi. And then we have to add our units. So if it was volume, it would be cubed. If it was area, it would be squared. But if it's just one variable like height or radius or something changing, it's just going to be meters per second, or whatever unit of time you have and unit of distance. So this is meters per second. -2 over 9 meters per second. And let me check that. Oh, ah, oh my God. Yep, that's right. So that's how you would solve a cone problem.